Well, I've been fiddling around with the circuit, and one thing I learned while I was gathering the data for the chart, there are 24 different possible combinations of the switches taken one at a time, or taken as a singular state, not considering sequencing. And it taught me in the course of just very shortly on in the course of doing it, the chart. The inner lamp, do I have this right? No, the outer lamp, lamp number 1. The outer lamp is so important. It cannot be off, or else the power source, the amperage sine wave, at times, not too infrequently, quite frequently, at times the amperage will be 180 degrees out of phase with the voltage, and of course that's no good. So I realized, a lot of these devices, they put a resistor or a lamp or something as a minimal load, teensy little thing, just to make sure you have something when you turn it on, or else something could drastically go wrong. So, remembering that, I decided to put a little resistor, the same ohmage as the lamp. At the time, it's standard, the lamp comes 180.08 ohms when I was powering it. So I put a 180 ohm resistor in parallel with the lamp. And then eventually I raised the ohmage on the lamp anyway by raising its wattage, minimum on wattage, so that it wouldn't come on unless it was sufficient watts driving it. So I raised that from the hundreds. It was standard. These were like 100-watt simulated 100-watt lamps. I raised them to 2 kilowatts each, the two inner lamps and the outer. I tried taking out the spark gaps with their capacitors, the 47 nanofarad capacitors, and it turned out to be a fiasco because the waveform of the AC power source became highly irregular, so irregular, and a few of the other scopes too. They were just up and down, oscillating. So once the spark gap starts to function, it seems to create like a metronome effect or a timer circuit kind of effect of keeping things in a nice consistent beat, a rhythm. It gives a good rhythm to the circuit that's fairly consistent, and the waves. The other thing was the waves were wavering up and down. The either the amperage or the amperage with the voltage. Yeah, no, some of the scopes they were, and some of them got suppressed. They went below the baseline. I think it was the amperage. Either the amperage would get suppressed, and the voltage would, straddle the midline, or else both would waver up and down. And I've seen that before when I was initially experimenting with this topology of an over-unity circuit, that a lot of things would oscillate, wavering up and down the waves. They would not stay centered straddling across the midline of the scope, of the oscilloscope readouts. So actually it was, and then the other thing was the wattage on the lamps couldn't not be too high, because that would do screwy things with the waves. So I'm learning slowly to tweak this, but so far I have not eliminated anything, and I just added a little bit. One resistor to straddle the outer lamp number 1, the far left lamp on the schematic, to be always there, a minimum resistance comparable to one lamp. Because that's essential. The inner lamps can be turned off because they're extra. They're tied to the inside of the LMD module. Oh, and I tried taking out the capacitors of the LMD module did not work. They actually are needed. It's very interesting. I'm trying to see if I can scale the thing down. Now, I haven't tried to see what would happen if I took out one spark gap versus leaving both in. That's something else to try shortly. What else? Well, let me think. Well, the chart is interesting. I thought it was going to be 32 combinations possible because there's 5 sets of 8 switches. So there are several that are in pairs, and then the rest are singulars. But it turns out the on-off switch cannot be off. The spike no, it works this way. The spike cannot be off and the on-off switch cannot be off both at the same time. So in other words, the spike switch, which goes to either drain toggle side or else it toggles to spike, either spike or toggle. Spiking means the energy is being supplied from the source just to the inside of the LMD module rather than the outside, while the on-off separately will feed the outside. So you could do both at the same time, feed the inside and the outside at the same time. But for both to be turned off from an external power source, you're just in draining modes, and you can fiddle with that all you like on your own. I've done that. I mean, that's why I set up the drainage the way I did, because I wanted it to drain quickly, but that doesn't teach me anything. So that severely reduced. It took away, well, it subtracted from the 32 and reduced it down to 24, so it took away 8 options. So the chart's now only 24 options long, and basically I'm just reading out the voltages, and putting it in putting that as data in the chart. So I get to see, and so far nothing weird. I mean, it's all pretty much the same. Everything's up in the kilovolt range. Except I did learn that when the outer lamp is shut down, it's no good. When the power is going through the circuit, it messed up the waves. I don't mind in the beginning they waver up and down, but because they're converging on a target where they want to stay. First they go too high, then they go too low, and then the next time they don't go as high as they did before, and then the next time they don't go as low as before. So I know they're converging, and this is all in microsecond time anyway. So in maybe 2 seconds, or well before that, they tend to stabilize. And on the scope, I like to put the negative voltage and the positive voltage both to read out, because they both kind of vary. One will vary more than the other. Usually the negative, it seems like, sometimes will vary more than the positive one. Yeah, I like to see that, because sometimes the waves I can see, but I like to see the numbers too. I can see that a wave will be depressed. It'll be shifted into the negative range, both the peak and the trough of that wave, the whole wave, and it's really bizarre. So seeing the numbers helps emphasize that I have to try to create a semblance of aesthetic balance to a system that otherwise wants to throw everything off balance. I mean, inherently. But the spark gap is needed. The LMD module is needed, and there's other tweaks I'm going to have to try. This chart does not include another chart I'll have to do on the transformer and inner capacitor, the pairs, the 2 transformers and the 2 inner capacitors, the 2 central capacitors, because I thought I worked out some of those details, but I need to go through it more thoroughly. I just kind of did a few tests, but I need to chart it to make sure I don't overlook anything. So whether or not the primaries are on one side of the transformer or the other side, and what's their ratio, and what's their the Henrys and all that business. And what capacitors would go best with them. That's a lot of charting, actually. That run right there, at first I thought it would not be too involved, but actually it is very involved. So it's a whole other set of charts I have to do. Because I am trying to figure out, I'm trying to maximize the efficiency of this thing. Because I know it's a good topology, it's a good idea. The way it's arranged in general. But there are all these little details that need to be ironed out to make it work efficiently, and then decide whether or not, somehow decide whether, judge it, critique it as to whether or not it's actually practical, even as a simulator, as a simulated version. And I think I'm hoping, actually, I don't think, I think too much. I hope that when I make it a self-runner, when I take the outside and feed it back into the inside and don't use an AC source, that'll hopefully verify whether or not I did any good, if I did a proficient job of tweaking it. I'm going to do the same thing as Clarence did with Barbosa and Leal. I'm going to have a portion of the output go through a battery charger that's not a smart charger, because I can't guarantee to myself whether or not I'll be able to find any information on the internet on how to create a simulation of a smart charger circuit, because it sounds like it's kind of intelligent and kind of complicated. But a simple charger circuit, I'm hoping I'll do that, and then stick a battery in there, a DC battery, and then a sine wave inverter, an AC sine wave inverter. So, wait a minute. So that might prove, using the external circuitry to self-run this, might serve as a perspective point outside this circuit with modules that, two modules that have to perform properly, and if they can't because they're being fed sloppy waves, then I failed. Now there are two groups of components that tend to put the amperage wave 90 degrees ahead of the voltage, while the others tend to be right on the mark, sort of, more or less, when I'm doing everything right. The AC power source is one in which the amperage gets ahead of the voltage by 90 degrees, and I'm not sure that's a good idea. And if that's the case, if the circuit is having that impact, that kind of an impact on the source, what's going to happen when it has that kind of a influence on the sine wave inverter? Is the sine wave inverter going to accept it or not? I don't know. That's why I think doing a self-running mock-up will be the only test that I know of that will really test to see whether or not the circuit is operating properly and creating useful energy instead of creating just mud, basically. When I see all these, kilovolts, I say, well, gee, but it could be useless energy for all I know. The other problem is I don't know what I'm going to do about the spark gaps, or the neon bulb spark gaps, because they are always at kilovolts, and I don't know how to reduce them, and I haven't tried enough possibilities. I only tried a resistor in parallel, so I haven't tried a resistor in series. The resistor in parallel pretty much shut them. No, it did nothing, actually. It did absolutely nothing. Can't remember. Oh, I did. Oh. I tried putting a resistor in series with the power source. That shut down the spark gap. I tried putting a lamp in series with the power source right next to it. And that, I think, created an error message. I don't know, I can't remember. I've tried so many things, I've lost track of. Anyway, it's too late now for me to tell you what I tried because I didn't document everything. I'm just, the only thing I'm documenting are the charts. And that's to make sure I'm thorough with something that's in an area that's basically complicated. I don't want to overlook anything because, tonight I learned something. I've learned one thing: the importance of the outer lamp, lamp number 1, the lamp on the far left. What else? Another thing that's worrying me is that all throughout these experiments, and I've tended to overlook this, I'm pretty sure the power source is putting out megawatts and kiloamps. And that makes me think that I'm straining it. Because when I look at, it's putting out megawatts, but then when I look at the loads, the 3 lamps loads, are putting out, or consuming, whatever, kilowatts, not megawatts. So there's a big difference there. That means this source it's costing the source a lot of energy just to run the load at kilovolts. That's very stark, or explicit is a better choice of word. Explicit non-efficiency. Nothing I could say would be over unity. If anything, it's looks like vast under unity. Might be because I don't know what I'm doing. So that's why I think trying to create a self-running situation will really test whether or not this thing is actually producing over unity or not. Because I have a hard time understanding how to go about assessing what's happening. I really don't know how to analyze it. I'm just, for something like that, which is the whole point of this, instead I just try to make it look like it's, not like one of these cars where the timing on the engine is all wrong and it's knocking so severely that the whole car rocks back side to side and backfires. So I'm looking mostly at subduing the extreme anomalies without actually knowing whether or not it even is over unity. Just because it creates a lot of kilovolts doesn't mean it's over unity, although at first I thought so. Because I would see yeah, that's right. Well, that was the problem. Everything went skyrocketing that night, the 25th of February in 2017. Over 150 billion gigawatts on the lamp. But the power source wasn't far behind. It was behind it, though. And that's the only time I actually can safely say I actually was over unity. It's just that it was shooting through the roof. It wouldn't stop going up. And that was the only way to stabilize the waveringness. I couldn't get the wavering waves on the scopes to lock into place and stay stable without jacking them up so high that all they did was go up and never have a chance to come back down again. I never gave them the chance. I didn't want to wait and see because I was freaking out watching this thing. I freaked out, basically. I lost my cool pretty fast. So maybe that original design is the only one that works. Just be prepared. I should be prepared to add in plenty of load, because then the load was registering values that were 1,000 times, well, at least in the beginning, when I could read the numbers, 1,000 times more than the source. So I figured, okay, you subtract the source from the lamp, from the load, and the difference is a positive outcome on the lamp side, on the load side. So if anything, it looked like energy was gaining, being produced, But in that instance, the lamp was a very low wattage to make it light up, and so the kelvins, my God, it was like 200 million degrees Kelvin on the lamp. So if I had set the lamp to a higher figure, 1,000,000 watts, then, or a gigawatts, then it would have never gotten so hot, and its resistance would have been slightly higher. I could have put in a resistor next to it and made that a gigaohm of resistance or something, I mean, there's different things I could have done. And I could have had them switched in at some point. That's what I'm learning, is that you have to keep these things, the heavy-duty loads, switched out because you can't afford to suppress the spark gap from functioning. It has to function, or else the whole circuit is just useless. It just doesn't operate properly. And putting on too much load when you switch it on, immediately putting on too much load is a big mistake. So if the load is switched in, though, you can use that to regulate it. So maybe that's what I should do, is go back to the original circuit that went through the roof and fiddle with it some more, and employ some additional loads. See, the first load doesn't have to be a lamp, obviously. It can be just a resistor of 180 ohms, just like I'm doing now. And then I bring in the heavy stuff by degree, so they can be factors of 1,000 times, I guess. The first one I could bring in could be a kiloohm of, that's right. Yeah, I could use resistors. I could use 100 watt. There are two different ways I can do this, obviously. I can have a single 100 watt light bulb and just bring in various resistors, switch them in, and each resistor is like 1,000 times more intense than the prior one. So the first one could be a 1 kilo ohm resistor, and then a 1 mega ohm, and a 1 giga ohm resistor. That would probably be the safe bet to try first. And I was thinking, for the sake of clarity or thoroughness, to bring in other forms of load, an inductive load. So I could have coils of different inductance. Again, factors of 1,000. And I could bring, one of each, toggle. I don't know what the balance should be, but I'll find out. To represent the two types of loads was, that might be the only way to prevent it from going through the roof, provided that does not accelerate it even faster. Because when I cut the power, it skyrocketed so fast. I may have tried adding resistors before already and gave up because it didn't work. It just, didn't have any impact whatsoever, just went through the roof anyway at the same pace. I can't remember, but it might be the case. That might be why I gave up that way to try to regulate it. But the power source was under strain, just not as much as the load was, by a factor of 10. It was 10 times less. And I'm not sure how to shield the power source from strain. That maybe that's one of the various purposes of the neon bulb and the Barbosa Leal setup was to protect the source from that backwash of energy that would engulf the source. It wants to engulf the whole circuit, but may not be a good idea to allow to engulf the source. I'm not sure. It's almost as if the way I still think the neon bulb is connected in Clarence's replication of Barbosa and Leal. To me, it looks like a diagonal of sorts. It's not horizontal, or it's not parallel to anything, and it's not perpendicular to anything, which would be a shunt. Instead, or a shunt or short. Yeah, it's not in parallel and it's not in series. Well, it's not in parallel and it's not in perpendicular. But it looks like it's on a diagonal style connection. Maybe that's the only way to protect the source, is you protect one leg on a diagonal to the other leg, not perpendicular and not parallel. Because I was never sure how you're supposed to protect the source. I just assumed you can't protect it. But that's not good electrical engineering. And I still have the question of whether or not I need 2 spark gaps or 1. And on a diagonal, that might work because you can't put the spark gap too close to the source. I've never succeeded doing that. It always messes up how the two of them get along. The spark gap always has to be somewhat remote, and a diagonal would fulfill that criteria. So, the only place I can think of to put a spark gap on a diagonal instead of the spike, the power source spiking the inside, it spikes it on a diagonal. And it's the only diagonal pair of connections to the inside of the LMD module that's a singular diagonal. I don't do both because it would be ridiculous. I'd be, creating conflict or neutralization with the power source. So if I take out the spike, I could put in a spark gap there and take out the 2 outer spark gaps. And it would be a little remote from the power source, and it's actually the best place to put it because the voltage is always the highest inside the LMD module. Now that I think of it, probably have to shut off the inner lamps when I run it in normal power mode, or else they might mess up the spark gap. Gosh, that's an interesting possibility. So I'm looking to see if I can create protection for the power source. Because the spark gap actually functions as a metronome and as a filter in the same sense. Well, filtration based on metronome selectivity. That might be an interesting possibility, and then I'd reduce my spark gap to just 1. And it won't be lopsided, it'll be on a diagonal across the center. I'm trying to create symmetry as much as possible, because I know that will help enhance the regular behavior of this thing, because by its very nature it wants to be irregular and all over the place. I mean, my God, when I first started working with it, I was mesmerized by the scope waves going up and down, undulating like waves on the ocean. I mean, and I don't mean pretty sine waves, I mean messy sine waves of all types. I mean, it was just a mess. That's the easy part, is making them messy or irregular, or something that doesn't quite look right. The hard part is to getting everything to look nice and pretty. But that's the only way I know how to create a regulated over-unity situation at the moment. I mean, you undermine a large part of the over-unity that way, but at least you get it regulated. So I'm not sure I can use the original circuit that I was using and just add more load, because that seemed to have no effect. It was like it was invisible. This circuit literally couldn't care less how much load is there that it's frying. It's as if it's so narcissistic. It's as if the LMD module exemplifies narcissism at its finest, because it literally doesn't care what's going on outside itself, despite the fact that it's dependent on everything else that's outside of it, the power source, the spark gap. So, but it couldn't care less. It behaves as if the outside world, any part of the circuit outside itself, does not exist. It's truly bizarre. I mean, this whole thing is so bizarre anyway, in more ways than one, in several different ways. Well, I'm tired, but I'm excited to, I don't want to stop working. I'd love to keep working. In fact, I don't feel like going to sleep. That's why I'm making this video. But I'm mesmerized how fun it is to play with this thing. And as much as the charting was a lot of secretarial busy work, getting the tables on the chart to figure it out, and how to put the data in the table, and oh god. But it was the only way to methodically go through this and actually learn something for a change that I couldn't have learned just by try this, try that. I have to at least start to become organized so that I don't overlook anything, and I understand what I'm trying to look for, instead of just having a vague guess, patchwork of an idea. That I actually have a very well-defined idea of what I'm trying to look for when I'm looking for something. I mean, now it comes the real work of trying to be thorough to make this practical, to make it operational. So, whatever. It seems not so likely I'll ever make a pulse DC unit out of this. I don't know. It just doesn't seem likely. Although it should be interesting to try, though. I mean, I'm not going to give that up, but I don't know. I'm not hopeful. I'm a little bit of a cynic at this point. I understand there's another variety of AC. I forget what it's called. That's different than our AC. It's in a peculiar or unique way. I can't remember. I read it. Should have taken notes. Anywho, I have lots of time to cover all these things, and it's oh so fascinating.